I am Dr. Anita Thomas. Today's class is on section 1.5 exact equations. An equation of the form m of x comma y dx plus n of x comma y dy equal to 0 is said to be exact if it can be written as the total derivative of a function f, namely dou f by dou x dx plus dou f by dou y dy equal to 0. In our vector calculus classes, we studied that m of x comma y dx plus n of x comma y dy equal to 0 represents a conservative field if it can be written like this, that is the total derivative of a function f of xy, and we learned that its solution will give a potential function, and the way to the result, the answer is integral d of f of xy. That means integral of the total differential of a function f of xy equal to c. The final answer is, or the solution is, f of xy x comma y equal to c, and f of x comma y equal to c represents a potential function. We already learned a necessary condition for exactness. Here it is the same as that in vector calculus. From the two equations above, we found that dou f by dou x is m of x comma y and dou f by dou y is equal to n of x comma y, which implies dou m by dou y. That means we differentiate m with respect to y partially. We will get dou square f by dou y dou x, and dou n by dou x is equal to dou square f by dou x by dou y, which is equal to dou square f by dou y dou x by mixed integer theorem. Mixed derivative theorem. Thus, dou m by dou y is equal to dou n by dou x. So this is the necessary condition for exactness. Now shall we move to problems. Determine which of the following equations are exact and solve the exact equation. So first one is x plus 2 by y into dy plus y dx equal to 0. First we write in the standard form y dx plus x plus 2 by y dy equal to 0 implies m is equal to the coefficient of dx, that is y, and n is equal to x plus 2 by y, which implies the partial derivative of m with respect to y is equal to 1, and similarly dou n by dou x equal to 1. Thus we found that dou m by dou y is equal to dou n by dou x. Therefore the given equation is exact. Now I am giving three methods for solving an exact equation. First two methods are identical. First method, m is equal to, from the question, m is dou f by dou x equal to y. Now dou f by dou x is y. For getting f, we have to integrate this expression with respect to x. Thus we get f is equal to xy plus phi of y. See, we here take the constant of integration as phi of y because we are integrating with respect to x, and while we integrate with respect to x, y is considered as a constant. Therefore, there is a chance of the existence of y here, or it may be a constant value, arbitrary constant value. Now, differentiating partially with respect to y, dou f by dou y is equal to x plus phi dash y. But from the definition itself, we know that n is dou f by dou y, which is from the question x plus 2 by y, which implies these two equations implies x plus phi dash y equal to x plus 2 by y. Since the RHS of both the expressions a and b are equal, so x plus phi dash y is equal to x plus 2 by y. From this, common factors get cancelled, getting phi dash equal to 2 by y. Our aim is to find out phi of y. So we have to integrate it with respect to y. We will get phi of y as 2 ln of y plus constant of integration d. Therefore, from equation number 3, we will get the solution by giving the value of phi of y. Thus, f is equal to xy plus 2 ln of y plus d. From our text, we represent the solution in a particular way, f of x comma y equal to c. Therefore, we write it as xy plus 2 ln of y plus d equal to c, which implies xy plus 2 ln of y equal to c tilde. C tilde is c minus the constant, c minus the arbitrary constant d. Now, second method. There we took first m, here we took n. So, n equal to dou f by dou y by the definition of exact equation, which is equal to x plus 2y. Here we have to integrate it with respect to y, because from this expression for getting f, we have to integrate it with respect to y. Thus f is equal to xy plus 2 ln of y plus phi of x. As in the previous case, we are integrating with respect to y, so x may be arrived here as a constant, or it may be an arbitrary constant. Now, dou f by dou x, differentiating with respect to x, we get y plus second term is of y, so it is 0 plus phi dash x. We took it as a dash equation, but from the question we know that dou f by dou x is m, and in the question it is y. So equating a dash and b dash, we get y plus phi dash x is equal to y, which implies phi dash x is 0. Our aim is to get phi of x. So integrating this expression with respect to x, we get phi of x is equal to t tilde and an arbitrary constant. Now the solution is f of x comma y equal to c. That implies f is xy plus 2 ln of y plus d tilde equal to c. Then, as in the previous case, xy plus 2 ln of y equal to c minus tilde equal to small c. It is the same as the previous one. There is a change, maybe a change in the constant, arbitrary constant only. Both are the same. Second question. Third method, we have dou f by dou y equal to x plus 2 by y and dou f by dou y equal to y. Now you consider these two terms. when there is a function, if you differentiate it with respect to y, you will get x. And here is a function. When you differentiate it partially with respect to x, you have to get y. That means f should contain a term x, y, x into y. Now consider the second term, 2 by y. Here is no term. So 2 by y. That means whenever you differentiate an unknown function f with respect to y, you have to get 2 by y. That means that the function f should contain 2 ln of y. So by inspection, we can find out directly the solution. F of x comma y is equal to xy plus 2 ln of y equal to c. So use these three methods, any of the three methods. This is the easier method to find the solution. Second problem, sin x tan y plus dx plus 1 into dx plus cos x sec square y dy equal to 0. M is this one and n is this one. By differentiating m with respect to y, we get sin x sec square y, and with respect n with respect to x, we get minus sin x sec square y. So dou m by dou y not equal to dou n by dou x, so it is not exact, so we can't proceed. Now the third problem, y minus x cube into dx plus x plus y cube into dy equal to 0. So m is y minus x cube, n is x plus y cube, implies partial m by partial y equal to 1 and partial n by partial x is equal to 1. So they are equal, therefore the given question is an exact one. Now I use the third method from the expression, or by the definition, m is equal to dou f by dou x, that is y minus x cube, and n is equal to dou n by dou y, which is equal to x plus y cube. As in the last discussed question, it is y by y, here it is y and x. So f should contain a term xy. Now we can check the second terms of these two expressions. Here is a negative sign and x cube, that means no y. Here is no y. That means there is an unknown function whose derivative, partial derivative with respect to x is x cube. Then evidently it is minus x raised to 4 by 4. See, if you differentiate it with respect to x, what happens? Partially with respect to x, we will get a minus x 4x raised to 4 by 4, 4 get cancelled. Similarly, the case of y cube, that means f should contain a term y raised to 4 by 4. Thus by inspection, we obtain the solution as xy minus x raised to 4 by 4 plus y raised to 4 by 4 equal to c. So do the homework and do watch my next video for more problems from the exercise of section 1.5 exact equations for the 5th semester B.Sc students. Thank you.